All right, so we're kicking things off today with a deep dive into the world of Johannes Kepler. Talk about a pivotal figure in the scientific revolution. Born back in 1571, it's wild to think this guy started in theology before his mathematical genius, like, skyrocketed him to the forefront of astronomy.
Totally. And what's so cool for someone with a background in philosophy like yourself is that even with all that astronomical fame, he really saw himself as a philosopher at heart.
Right, like he wasn't just about mapping the stars. He was digging deep into, as he put it, the innermost structure of the cosmos. Deep stuff.
Absolutely. And speaking of deep stuff, you brought this awesome resource to the table, the Stanford Encyclopedia of Philosophy entry on Kepler.
Yeah, it's a real goldmine. And what we're going to do today is, unearth those core philosophical ideas woven into Kepler's work. Those surprising links between his revolutionary science, his philosophical leanings, and even his theology.
It's going to be a journey.
It is, and I think our listeners are in for some serious aha moments because Kepler was wrestling with questions about reality, the role of math, like those big, persistent questions that philosophers are still debating today.
Oh, for sure. Even when he was up to his eyeballs in astronomical calculations, he craved philosophical speculation. He actually described it as his only delight compared to what he called the treadmill of mathematical calculations.
Wow. That really shows you where his heart was. And when you consider the major intellectual forces shaping his work, we see this really cool dance between, Platonism, with its emphasis on geometry as the foundation of everything, and Aristotelianism, which really championed observation and figuring out causes.
Yeah, he wasn't just picking a side. He was trying to create a synthesis to bring those two giants together in his own way.
That's so interesting. And what's really wild is that this wasn't just some theoretical exercise for him. He was convinced that the way the universe is arranged, its structure, its alignment with the human mind, it was all a reflection of the divine.
That's powerful. Like astronomy done with a philosophical lens was the ultimate way to understand God's creation.
Exactly. And that's where his early work, Mysterium Cosmographicum, comes in. You can really see the heavy influence of Platonic and Neoplatonic thought there, especially that idea of the cosmos having this fundamental geometrical architecture.
Totally. And that's where his polyhedral hypothesis comes in. Picture God as the efficient cause, the one who kicks off creation, using the 5 regular polyhedra, the cube, tetrahedron, octahedron, all those as the formal cause, the blueprint.
Wait, so he's saying God used these perfect geometric solids, as building blocks for the universe?
Pretty much. He even drew this diagram showing those solids nestled between the spheres of the planets.
Okay, so not just a random scattering of stars and planets, but this deliberate geometric order.
Exactly. He even took this geometrical thinking further, reinterpreting the Holy Trinity through geometry. The center represented God the Father, the sphere's surface represented God the Son, and the space in between, defined by their relationship that was the Holy Spirit. That's deep.
Whoa, that is taking it to a whole other level. But we should remember the intellectual history he's drawing from. Those 5 regular solids, they've been around since, the ancient Greeks.
Oh yeah, going back to the Pythagoreans and Plato's Timaeus, then rigorously explored by Euclid, and they saw a huge resurgence in the Renaissance. Kepler was tapping into a rich tradition.
He was. And he used this polyhedral hypothesis to justify the Copernican system in what he called an a priori way. That's knowledge that's independent of experience, right?
Right, as opposed to a posteriori, which relies on observation. Kepler felt Copernicus's argument for a sun-centered system was more a posteriori, based on what astronomers were seeing. He wanted a deeper reason for the planets' arrangement, both their number and their distances, something more fundamental.
So he was basically critical of the Osiander, or the Wittenberg interpretation of Copernicus, the idea that it was just a handy mathematical model, not necessarily a true reflection of reality.
Exactly. Kepler was a realist through and through. He believed the Copernican system was true, not just a useful tool. And his polyhedral hypothesis provided that deeper grounding for him.
And this fascination with geometry wasn't just a phase, right? It continued throughout his career.
Oh, totally. In his later work, Harmonious Mundi, he made significant discoveries with tessellations and even identified 2 new regular star polyhedra, the small and great stellated dodecahedrons.
Wow, those are mouthful.
They are. And he even kept using the Platonic solids in Book 5 of Harmonious Mundi to try and figure out the number and distances of the planets. Though he did acknowledge that Tycho Brahe's more accurate observations showed some limitations to his initial hypothesis.
Seems like he was constantly balancing the elegance of abstract geometry with the increasing precision of empirical data.
You got it. And that tension becomes super central when we look at his epistemology and philosophy of science, which were honestly way ahead of their time.
Right. Where do we even start?
Well, we can break it down into four key aspects: realism, causality, his philosophy of mathematics, and his unique take on empiricism.
Okay, I'm following so far. Let's start with realism. We touched on it earlier, but how did that commitment to realism shape his approach to science?
Well, as we said, Kepler's realism was tied to his staunch defense of the Copernican worldview. He wasn't just proposing a new model, he was arguing for the actual physical arrangement of the cosmos with the sun at the center.
And his defense of Tycho against Ursus seems to be a crucial text for understanding his stance on knowledge.
Absolutely. While it started as a fight over who discovered what first, it became this significant work on the nature of astronomical theories, the role of causality, the whole realism-instrumentalism debate, and even Kepler's critique of skepticism. Some scholars put it up there with Bacon's Novum Organum or Descartes' Discourse on Method.
Wow, high praise. So, like Osiander, Ursus had this fictionalist view of hypotheses, seeing them just as made-up things to explain observations, not necessarily reflecting reality.
Yeah, exactly. He echoed that idea that hypotheses were just computational tools, no claim to actual truth. Kepler strongly disagreed. He said that just because a hypothesis predicts things accurately doesn't automatically make it true. To think that way is falling into the fallacia affirmationis consequentis, the fallacy of affirming the consequent.
Right, so just because something works doesn't mean it's the whole truth. But it seems like there's a difference between Kepler's realism and what we call modern scientific realism.
Sure. Modern scientific realism generally says there's an objective world that exists independent of our minds. For Kepler, truth was tied to his theology. He didn't think nature or our minds were fully separate from God's mind.
Makes sense in the context of his whole worldview. So let's move to causality. How did he bring the idea of causes into astronomy, which was traditionally all about math?
That was a game changer. Astronomy had always been about mathematically describing the patterns of motion in the heavens. Kepler, with his realist viewpoint, wanted to explain those motions with physics. He was aligned with the Aristotelian idea of understanding the why behind natural phenomena.
So he was searching for the actual physical mechanisms that made the planets move the way they did.
Yep. Even in Mysterium Cosmographicum, he hinted at a power from the sun that affected the planets based on their distance. That was super radical for the time.
And his later work, Astronomia Nova, the title itself tells the story, new astronomy based upon causes, or celestial physics. He was moving beyond just describing motion to explaining it through causes.
Exactly. He insisted his work was about physics, about the forces in the universe. He famously replaced Copernicus's abstract mean sun with the real physical sun as the source of influence. He also threw out the idea of planets being moved by immaterial souls, anima, and proposed the concept of a physical force as the driver of their motion.
So what were his ideas about those forces? What was causing those celestial movements?
He considered a few things. He was really into the idea of a magnetic power from the sun, influenced by William Gilbert's work on magnetism, de magnete.
Makes sense.
Yeah, he envisioned these magnetic fibers connecting the sun and planets, with the planets themselves having magnetic polarity. And he thought the sun's rotation somehow powered their orbits through this magnetic interaction. He also considered light and even hinted at something like gravity, but magnetism was his main explanation in Astronomia Nova.
But then there's that problem of planets moving slower than the sun's rotation. How did he explain that?
Good question. He came up with this concept of inclinatio ad quietum, basically, an inherent tendency for matter to resist motion, to stay at rest.
Inertia.
Kind of a precursor to that, yeah. He saw it as counteracting the sun's force and regulating the planet's speeds.
Interesting. And did this focus on causal explanation continue in his Epitome Astronomia Copernicanae?
It did, though in the Epitome he starts with his third law, the harmonic law, as a general cosmological statement, rather than starting with the first two about individual planets. He completely rejected the traditional idea of celestial spheres and moving intelligences guiding the planets. He argued that the elliptical orbits pointed to natural causes.
So no more mystical beings pushing the planets around.
Right, and he said the planets have a kind of inertia, a resistance to changes in their motion. He repeated the idea of the sun as the source of notive power, vix motrix, transmitted through light and magnetic rays. The elliptical paths resulted from a balance of attraction and repulsion. It's worth noting that he still relied partly on a sol in the sun to explain its rotation, though. A bit of a holdover from older ideas.
A blend of old and new, for sure. Now let's talk about his philosophy of mathematics. It's clear math, especially geometry, was incredibly important to him.
Oh, absolutely. Kepler was deeply trained in math, and for him, it wasn't just about calculations. It was a key to unlocking the secrets of reality. His Harmonissa Mundi, with 2 whole books dedicated to math, is his main work on this. He even said in those sections he was acting as a philosopher in this part of geometry.
So he saw math as a way to do philosophy.
You could say that. He had a lot of respect for Plato and Proclus's ideas about math, but he also found some common ground with Aristotle, believing that even Aristotle acknowledged the existence of mathematical entities in some way. Kepler saw his own work in Harmonissa Mundi as continuing what Euclid did in the Elements, particularly that exploration of irrational numbers in Book 10.
And wasn't the concept of constructibility central to his philosophy of math, like using only a ruler and compass?
Exactly. He believed that for a mathematical concept to be truly knowable and certain, it had to be constructible using only those classical tools. That was his gold standard for mathematical truth. He even applied this to astrology and the principles of musical harmony.
So if you couldn't construct it geometrically, it was somehow less fundamental.
Yeah, he held this very Platonic view of math, seeing mathematical things as having a real existence apart from the physical world in our minds. He wasn't as into the Aristotelian focus on abstraction from sensory experience, and he was even skeptical of algebra, at least how it was in his time, because he saw it dealing with discrete quantities, like numbers, instead of the continuous magnitudes of geometry, which he felt were more fundamental.
And didn't he use the heptagon, the 7-sided figure, to make this point?
He did. You can't construct a regular heptagon with just a ruler and compass. So Kepler reasoned that God, being perfect, wouldn't have used such figures in creating the universe. For him, that was a sign of its lack of primary importance in the cosmic order.
So approximations, which are so common in modern math and physics, weren't really his thing?
Nope, he called them painful and precarious. He was all about those exact geometric relationships. Some recent research even suggests that he used what they call a Pythagorean methodology when he was studying light refraction. It was all about sameness is knowable by sameness and trying to avoid the concept of infinity in his explanations.
Fascinating. Okay, last piece of the puzzle. His take on empiricism. How did observation and data fit into his theoretical, math-heavy world?
Well, even though he loved his theories in math, Kepler always emphasized the importance of experience and data to back up his ideas. You can see this in his letters to other scientists like Herwart von Hohenberg and David Fabricius, where he stressed careful observation. And in Mysterium Cosmographicum, he painstakingly compared different astronomical tables to find support for the Copernican system.
Right, he was committed to that. He even told a story about Copernicus admitting that observations weren't always perfect. But I feel like his view of data really shifted once he got his hands on Tycho Brahe's observations. Talk about a game changer.
Oh, absolutely. In Astronomia Nova, Kepler flat out says how much he relied on Tycho's data. A big chunk of the book is dedicated to presenting and then disproving the vicarious hypothesis, which he thought was the best model you could get using traditional astronomy based on Tycho's meticulous Mars observations.
And that's what led to that famous 8 minutes discrepancy in Mars's position, right? The one that Kepler said would lead the way to the reformation of all of astronomy.
The one and only. That tiny difference forced him to ditch the idea of perfectly circular orbits and ultimately led to his discovery of Mars's elliptical path. It's also considered one of the first times someone explicitly acknowledged and dealt with observational error in astronomy.
So he wasn't just a theorist, he was wrestling with real-world data. And this wasn't limited to astronomy, right?
Nope, he also emphasized observation in his optics research, which was often driven by disagreements between the theory and what he was seeing in his experiments. He even built his own instruments for more precise measurements.
Wow, hands-on scientist.
He was. Of course, we have to understand his idea of experimentum within the context of his time, particularly the use of tools like the camera obscura. But even in his work on harmony and astrology in Harmonissi Mundi, he was looking for empirical backing. He used weather data for his astrological predictions and did acoustic experiments with a monochord to refine his understanding of musical intervals. He even questioned some old Pythagorean assumptions based on what he found about consonant intervals like major, thirds, and sixths. So even with his theoretical leanings, he understood the need to ground his model of the universe in actual observations.
Okay, so we've got this rich philosophical foundation. His realism, his hunt for physical causes, his unique math philosophy rooted in geometry, and his nuanced approach to observation. All of that set the stage for his most famous contributions, the three laws of planetary motion.
Precisely. Those laws, which are now like Astronomy 101, didn't just appear out of nowhere. They were the direct result of his deep philosophical commitments and his radical reworking of the Copernican worldview.
He didn't just tweak things, he completely changed how we understand planetary motion and the structure of our solar system.
Right. And from the beginning, he was fiercely defending the reality of the Copernican system, approaching it with this a priori conviction.
He was convinced those first two laws in astronomia, nova elliptical orbits with the sun at one focus and the law of equal areas, they were revolutionary.
Oh, for sure. They completely overturned centuries of assumptions about perfectly circular orbits and uniform planetary motion, assumptions held even by Copernicus, Tycho, and initially even Galileo. Kepler was the one who showed definitively that planets change speed as they move along their elliptical paths and gave a physical explanation for it.
And then a decade later, in his Harmonices Mundi, he publishes his third law, the harmonic law, which he later elaborated on in Epitome Astronomiae Copernicani.
Yes, this law shows a precise mathematical relationship between a planet's orbital period and its distance from the sun. In modern terms, it's T1, T2, 2 equals A1, E2, 3, or A3, T2 equal K. It basically says there's a predictable link between how long a planet takes to orbit and how far away it is. This was like the holy grail for Kepler. It showed a profound harmony within the solar system, where planets weren't just doing their own thing, but were interconnected in this larger cosmic order.
Which brings us to harmony. It seems like for Kepler, it wasn't just about musical sounds or pretty mathematical ratios. It was something much bigger.
You got it. He considered Harmonices Mundi his most important philosophical work. Harmony for him was this universal principle, representing the ordered and interconnected nature of everything. Music and those Pythagorean ratios were part of it, but it went way beyond that. It encompassed his philosophy of nature, his psychology, even had social and political implications. He dedicated the book to King James I, hoping it might shed light on achieving harmony in church and state.
Wow, he saw it everywhere. He even differentiated between sensible harmony and pure harmony. What did those mean?
Sensible harmony was about the harmony we experience through our senses, like musical consonants or pleasing proportions in visual forms. He explained this using Aristotle's categories of quantity, relation, and quality, but with a twist. He said our minds or souls play an active role in recognizing these harmonies by comparing them to an internal archetypus.
So we're not just passively taking in sensory information, we're actively comparing it to something inside us.
Exactly. He even laid out a whole psychological theory, borrowing from those scholastic ideas about how sensory information, what they called species, enters the mind through the senses, gets processed by the imagination, and then judged by the sensus communis, this essential sensory faculty, and memory. Harmony arises as a qualitative relation based on shapes formed from regular figures.
So how did he explain our understanding of things that aren't directly sensed, like pure geometric shapes?
That was tricky for him. He agreed with Aristotle that numbers were less real than geometric entities, but he thought Aristotle didn't fully explain the reality of math and how we understand it. Kepler was more aligned with Proclus and defended Plato's theory of anamnesis, recollection, against Aristotle's tabula rasa, the blank slate idea. This puts him in those early debates between rationalism and empiricism, and some scholars even see stronger links to St. Augustine than to later German idealism, although he was well received by those thinkers.
Wow, he's really bridging those philosophical gaps. And this idea of cosmic harmony in the soul, it even extended to his astrology, which he practiced in a very specific mathematical way.
Yep. In Book 4 of Harmonices Mundi, he talked about aspects in astrology, the angular relationships between planets as seen from Earth. But he only kept the aspects based on geometrically constructible figures. He saw these geometrically significant aspects as archetypes recognized by the human soul. And he didn't believe in a direct mechanical influence from the heavens. Instead, he said the earth and all living things have souls that contain these geometric archetypes, and these souls are somehow stimulated by the symmetries and proportions they perceive in the celestial realm. He even famously said, the earth responds to what the aspects whistle.
So for our listeners who are into philosophy, it's clear Kepler was way more than just an astronomer. He was this deep thinker who tried to understand the universe through this incredible blend of math, observation, and a belief in an underlying harmony that connected with the human mind and soul.
Perfectly put. He wrestled with those big questions about what's real, how we know things, and the very fabric of existence. And he often made these amazing connections between seemingly unrelated areas of knowledge.
He did. And it leaves us with this final thought. Given how committed he was to both mathematical precision and this idea of a divinely ordered, harmonious universe, how do you think he'd view the debates we have today about math's role in physics, or that quest for a theory of everything? Did his way of understanding the cosmos offer something that maybe modern science, in its pursuit of purely physical explanations, has missed?
That's a really profound question, and one worth pondering. And for anyone wanting to explore Kepler's world further, the Stanford Encyclopedia of Philosophy entry is a fantastic starting point. And of course, there's his own writing and a ton of scholarship on his life and work.
Absolutely. Thank you so much for bringing this to us and sparking this deep dive into the mind of Johannes Kepler. It's been a real pleasure.
The pleasure was all mine.